Hello, world. It's me, Dennis, and welcome to another reasonably spontaneous conversation. This is my third conversation with Dr. James Crowe, who is an epidemiologist at Vanderbilt University. I hope I said that word right. And we had a conversation at the beginning of the COVID-19 pandemic. We had one at the middle, and now as we're coming sort of out of the end of it, or perhaps we're having a third conversation on what has been happening, what we've learned. Welcome, Dr. Crowe.
Well, thanks for having me, Dennis. It's great to be back with you.
Well, it's wonderful. All right, let's just start. Let's start at the end. Are we, in your eyes, first of all, give me a background of what did Vanderbilt and your team contribute to this effort over the course of the pandemic, so that we'll get local to you first, then we'll go global.
Right. Well, there's about four things you can do for these sort of infectious events. One is what people call non-pharmacologic interventions, which is masking and PPE and distancing. So MPI. Then there's small molecule, like chemical drugs, like aspirin's a drug, you take it by mouth by pill. So those are small molecule inhibitors. The third thing are vaccines. That's sort of the big goal, is to get vaccines that are long lasting. And the fourth thing is a really interesting kind of hybrid technology called monoclonal antibodies. And people mostly have heard about this. The president got antibodies from Regeneron when infected and so on. And so our group has a longstanding interest in making human monoclonal antibodies, and we have a high level of expertise. And the government turned to us, specifically DARPA, one of the agencies of the Department of Defense, and said, "This is for real. We need you to go as fast as you can. Give us monoclonal antibodies." And we took survivors who had been infected, actually in Wuhan in December 2019. Several months later, we got blood, and in 25 days, we had discovered very potent, strong antibodies that would inhibit the virus, and we passed them on to a pharma partner, and they've been working on those ever since, and they've now finished a number of trials that show that these antibodies can prevent infection. We have long-acting antibodies where you can get a single shot, not an infusion, and these will protect you for many months. We predict for probably a year. And so we're hoping any day now the FDA will approve those, or at least authorize those under EUA. So that was our main contribution, was making human antibodies that could be used for prevention. And this is going to be targeted at immunocompromised people. Yeah, there are millions of those people in the U.S. and they can't really be adequately vaccinated. So we've got vaccines, but not everybody can get them. So our antibodies will be used in those who cannot be vaccinated.
One of the things that I found so interesting when we talked about our middle segment was that you said that the science had that the truncation, the need to be able to have the speed, forced you to relook at your testing protocols, what you're doing. Please correct me on anything that I'm misspeaking about, but that it really gave you an opportunity to be able to look at things in a new way. And has that continued?
Right. Well, we have sort of a plethora of riches that actually can be debilitating, and so what's happened in our field has been very beneficial, and that is a convergence of amazing technologies. And each one of these technologies has an exponential expansion in capacity. So one of those would be what's called next generation sequencing. And this came out of Human Genome Project. We can sequence billions of cells or antibodies all at one time. So next generation sequencing, really explosive technology. And then another area in biology that's really grown is called synthetic genomics, or synthetic biology, where we can take a sequence, it's just letters on a page or a computer screen, and we can make the DNA, and we can actually make that molecule in the lab. So it's sort of like having a desktop printer where we put the letters in and the DNA comes out, and now we can make thousands of antibodies at a time. So the synthetic genomics revolution occurred in the last few years. And then there's another area that we're really excited about. There are instruments that we used to use a bucket, and then was a cup, and then we use a little tube has been the technology for decades. But now engineers have built microfluidic devices, which are tiny little plumbing devices, and we can put individual single cells from a human being into a little compartment and study those. We can watch them with a movie, we can test them, and we can do tens of thousands at a time. So that's called microfluidics. So if you put together the billions of sequences and the ability to make those sequences in a lab and the ability to put hundreds of thousands of cells into microfluidic devices, we now have the ability to make as many antibodies as we want. And that generated a problem for us because we had too many. And so doing our normal perfectionistic, reproducible type of science where we do things over and over and until we're good with it, we had to do more kind of qualitative screening where we say,
Sure.
Anything above this level is good enough, keep moving. And we still had too many. So we just kept setting bars and jumping over them. And, it's actually pretty difficult to go from tens of thousands down to these are the two we want to use. And probably many of them would have been adequate. But we ended up, focusing on a couple of antibodies that have turned out to be fantastic. And it was really rewarding in the end. But it was very different from conventional science, which is a little more methodical and reproducible.
So what was your role in all this? I mean, I can imagine, here you have a lab, you have people who are working in the lab. What does your role in this happen? What kind of problems are brought to you? What kind of decisions are asked for you to make?
Well, sometimes I ask myself that. I actually work with some executive coaches, and the central question is like, what is my job? What am I supposed to be doing? And, there's a balance. So we have a large group in my lab. There are about 50 people, and they're from very diverse backgrounds of medical people, MDs or RN types of people who deal directly with the individuals who were affected by the disease. And then we have laboratory people who pipette. But we also have a bunch of project managers who know how to listen to calls, make agendas, make action plans, and then follow through. And that's very important. The project management is essential. So we have all these people, and we built a structure that we think of as sort of self-managing. It's an organic entity where it should be taking care of itself. So theoretically, I'm not supposed to be telling people what to do every day. They know what to do, and they help each other out.
Absolutely.
And so I think my role increasingly is a little more strategic and trying to look ahead of the group, so that the group's moving as fast as possible, but making sure they have everything they need to do their jobs and to do it in sort of a frictionless manner. And so part of it is money, making sure there's enough money and going over budgets.
So you're a rainmaker. Do you go and propose for grants or or get directions and going that? Is rainmaking part of what you need to do?
Absolutely. I'm constantly writing grants and contracts because these are time limited, and as soon as you get them, the money's running out. So we live sort of grant to grant and contract to contract. So I do a lot of that, but even that is not all on me. I have a team of very talented administrators and
Sure.
who think about that. But thinking, who's our customer, who's our stakeholder, who has the money, who wants what we offer. That's part of what I'm trying to do, is align our capabilities with people who want what we do. So raising money, also trying to recruit talent, because I'm in an academic environment, and people come here because of the mission. They want to participate in something that's going to change the world. But our salary scales are lower than industry. We have industry people looking around on my website, and they call up my people and hire them away for higher salaries. And, I encourage them to go. If it's good for their career and they make more money, more power to you. So I think, bringing in talent and training people who are willing, they're curious and willing to learn, but don't really know how to do things, to move them to a high competence level. That's a lot of what we do. And even training, graduate students, postdoctoral fellows, we do formal training that leads to new careers. And we do a lot of that. And Then there's brainstorming. I think that's actually a whole field of itself. How do you bring a diverse group of people together and have new ideas about things that have never been done before? And we play around with that. How do you even do that? And pandemic's been terrible because we're all in virtual and Zoom. So, we've had to even dig deeper. How do you brainstorm with a group of people when you're not even with them? So we play around with ideas like that.
All right. Well, one of the things that fascinated me about the moon mission, the original moon mission, that President Kennedy said that we were within at the end of the decade we're going to be. Well, there were so many ancillary, unknown opportunities that came out of that they wouldn't have known had they not gone on that. Has the same thing happened with you? Are you finding new things that we would not have known had we not had to go on this journey?
Well, yes, the space program is very interesting. I was just listening to an audiobook yesterday that mentioned the fact that 2% of the United States budget went to that space effort. So money helps, if you want to get large scale things. But also, this month I listened to the book Skunk Works, which is about how Lockheed Martin invented stealth technology, and they had substantial resources, but not unlimited.
No, and they had to do it with slide rules.
Slide rules, exactly.
I mean, so.
Yeah. Kelly Johnson, the guy's sort of the leader there. Yeah, never gave up his slide rule. So, of a relatively small group of people, I think that's a good model for us.
Yeah.
Who had very aspirational goals, things that could not be done. We got pushed on that. And an interesting thing, DARPA is always involved in these things. So stealth, GPS, the internet, originally.
The internet. We have the reason why we're doing this right now is because of DARPA.
Absolutely. DARPANet. So they have a special mix of fostering, the types of things and so we're one of the DARPA providers on making antibodies very quickly, and it's changed our mind about what's possible. So you asked, what have we learned? Wow, we can do so much more than we thought we could do. We can go so much faster. We can make so many more antibodies.
Yeah.
Now that we've experienced it once, it's kind of hard to go back to old way and do it the slow way. So I'm sort of feeling like, why don't we always do it the fast, amazing way? And the group's sort of catching up to that, because what we experienced was a little sort of a sprint mentality. Go as hard and fast as you go. And we came out successful, but you can't stay in an anaerobic sprint. Sprinters only sprint for 10 seconds.
Yeah.
So how to convert that initial, very intense, but intellectually and spiritually and emotionally expensive experience into more of a routine thing? How can we make it? That's the way we always do it, and we haven't figured that out fully.
Well, no, I think that's called life. You're going to have to do that for the rest of your life. It's one of those things where you constantly get better. Why would Tom Brady continue to go out and back out onto the field if he didn't continue to want to get better and to learn how to be able to do his craft and the side? How do you think we've done as a country when you look over it from a historical standpoint as we're looking back? Two things that I want to ask. First, I want to ask how do you feel like we approach this as an historical challenge, and where were some of the places, and where were some of the places that we needed to that we might approach it for the next time?
Well, there were a lot of wins. I think a lot of this stuff's miraculous. So one is sort of exploring the role of United States government or other sovereign powers. What's their role in research and development? And the U.S. government put a substantial amount of money in a very short time period into these discovery programs with a high level of accountability, and it was very successful. It's amazing what you can get, if you just put the resources in.
Yeah,
I don't think we knew that before. We had smaller resources, and things took a long time, and no one knew if you just injected a lot of capital in the system and then said people have to jump this high, could they do it? And the answer is yes. Scientific community has a lot of upside capacity that's not being used just because it's dollar limited.
Mhm.
That's pretty disturbing in some ways, because we're going to go back down because we have this, panic cycle, and then we'll go back to apathy.
Yeah, exactly.
So this actually has changed my thinking about what I want to do in my career. So we've been working, to go faster and faster. But we've already shown we can make antibodies in 3 weeks that are perfectly good for phase 3 trials, and they work in people. And I've been thinking, like, what's faster than fast? I want to make antibodies for all of the infectious diseases that cause problems in humans. And I want to do it ahead of any epidemics. I want to make them now, and I want to have them available in stockpiles. And when something happens, I want to send those antibodies in and interrupt that epidemic. And regardless of who's affected, even if it's very vulnerable people in another country, let's have these things ready ahead of time. So we launched an entire program called AHEAD 100 to make human monoclonal antibodies, our technology, for all of the 100 most likely causes of epidemics. And I am certain we can do it. This is not a pipe dream. We have the technology to do it right now, and the resources that we saw to be so fruitful for mRNA vaccines and antibodies and all the other things that we benefited from, we can do that right now. But the question is, do we have the political will to ask our legislators, to resource these things when we're not having a pandemic? I'm suspicious as a country that we don't have the will, we don't have the commitment. But if you think of the cognitive biases like Kahneman, Tversky, and all that, should we spend $20 trillion to respond to a coronavirus pandemic, or should we spend a few billion to get ready for 100? It's just completely obvious. It's not even a discussion. We should get ready ahead of time. I think about the metaphor of fires. Like, should we put a smoke sensor in our house and have a little handheld fire extinguisher in our house, or should we build bigger and bigger fire trucks that are faster and faster and wait till your house is burning and then call them? Like, no. In the fire, space, we put in smoke alarms and, tell people to put a handheld in their kitchen, and you can snuff it out right when it happens. That's exactly what we can do with epidemics. But, are we going to do it? It's much less cheaper than what we just did.
Much. And that's what I want to. All right. So in framing it as that seems to me to be, it answers every question on no matter where you land on the political spectrum, because that is you've hit a commonsensical preventative. Do you wait till all your teeth fall out before you ever go to the dentist? Do we do anything? Do you wait until your car breaks down on the side of the road before you ever get an oil change? These are not things that we're doing. These are the preventive maintenance for the human species.
Right. Well, the cost benefit is
huge. I mean, it's off the charts. It's not even a beginning. All right. Well, how was your sense of it from as a human being at looking at how the framing, the messaging and the framing of the coronavirus and masking and anti-vax and all that are out there? What was your how did that land with you?
Well, I have mixed feelings about it. The miraculous impact of biotech, and we got 95-year-old people out of their home jail with vaccination so they could go hug their grandchildren. I mean, that's just very moving that we were able to do that. On the other hand, the whole politicization of science and the hesitancy around miraculous drugs, it's pretty discouraging to me that that in our situation we're not achieving more trust and uptake, and why do we have such distrust in these things? My wife is a retired physician, but also now an accomplished nonfiction writer, and she just had a personal essay in JAMA last week. It's a very moving. I suggest people read it. It's called "The Taste of Hope," and what she says in the essay is that we were, she and I, and probably you, Dennis, were in the first generation to receive routine childhood vaccines. And polio was a big deal in the 1950s. People would lock their kids in the house and they couldn't go to the pool, and there was just fear. And when Salk and Sabin came up with vaccines, it was a national triumph. There were public-private partnerships. So the March of Dimes helped United States citizens collect the money so we could get this stuff out and vaccinate every kid in the country. And companies got involved, the United States government.
Yes.
Everybody was all in. And, my wife was, talking about the taste of the polio vaccine. She could still remember that experience.
Yes.
And she connects that, vaccination with hope that we're digging out of a dark time. And then, full circle, she went back and she volunteered to vaccinate in Nashville at Music City Center, which is where we were giving the public the first vaccines. And there was such excitement in the Nashville setting where elderly people were saying, I'm going to hug my grandchild. And there was just so much of a triumph feeling. And so I would say a lot of us are reliving the excitement of the impact of vaccines that we first felt as children when there were no vaccines and then there were vaccines, and it was considered a national triumph and a community positive experience. But this go round, 2/3 of people are experiencing that. And the other third are sort of in an ambiguous place. And I feel sadness about that. I think that's not good for them and for our country. And it has nothing to do with the technology. It has to do with our society and politics, and very complex.
And it is deeply complex. And this is where we want to figure out how we can go on from here. What is this place where we can communicate, where we can treat one another decently, and we can have disagreements and be able to go back in a sense of comedy, and to be able to do this together. I mean, it's an important piece. So, tell me what else is going on at Vanderbilt right now that you guys are into. I mean, are you looking into the fund? Is this the funding cycle that you guys want to do? What is your team working on right now?
Well, we are finishing up supporting the COVID efforts for our antibodies, which we hope will be, under EUA any day, hopefully. They've been at the FDA for quite a while. But we've sort of gone back to what we consider our day job. So we're working on Ebola, dengue, Zika, yellow fever, West Nile, Japanese encephalitis virus, viruses most people never even heard of, Susuga virus, Sutu virus. So we have the capacity in our group, because it's a large group and we have a lot of robotics and things, to have multiple projects going simultaneously. And we've gotten back to that. There were, during 2020, there was a lot of focus on COVID to the expense of all the other programs. But we're back to sort of full force of working on all these other viruses. And it feels good. I just feel an excitement about the potential, not so much to run, toward a burning house, pandemic, but to prevent things. And I think a lot of things we learned in COVID, it was sort of a beta test of using monoclonal antibodies in the public, and it didn't all go perfectly. We learned some things that don't work, and now we're adjusting in the current programs, and we know where we're going for the future ones, and that feels good. Now we know what we're going to be doing.
It almost seemed like I had this weird sense of it, and you can tell me if it has any validity, that this was a great stress test and a great test that will allow us, when the big bad comes along, we will have already done the homework to be able to address it. When something escapes that is an Ebola style or has that kind of or the plague kind of a sense. Is that a reasonable way to look at it?
Yes, I think in the circles in which I traffic, scientific and funding of science and policy and so on, you're starting to see discussions that I would call, from a military model, called the after action review. Yes. What just happened? what went well that we should do more of, and what went very poorly and we need to do something different. And you're starting to see thought leader meetings that are addressed to those issues. What did we learn? And I would say things like, there are a lot of positive things, not just the resources that I mentioned before, but like, should the public health people and the military people, are they at odds, or do they have conflictual missions, or do they have some mutual thing? And in COVID, obviously the entire world was at risk for fatal disease from COVID.
Sure.
So the military, at least in the US, the military and the public health, so DOD and HHS worked very closely, and that became an entity. That interface was called Operation Warp Speed, which is, we need to cooperate to go as fast as possible. And it was very successful. So we got to deploy things in the city and move stuff in. The military is very good at that, and very decisive. And they were very successful about deploying things out. And yet the whole medical and biotech and all that, HHS is also very, strong in that area. So I think their complementary assets were brought together. That was very exciting to see. You also saw public-private things happening. So philanthropists kicked in, as did U.S. government, as did foundations and academic and commercial parties. Everybody put in what they had. And I think that was a win. Like, we could and we should do that for problems that aren't really commercial. They're not made to make money. They're just to protect us. That was a win, where you saw everybody in together. But then a lot of stuff's broken, like the equity of access to diagnostics or any of the tools we have now. It's still not fixed, in my opinion. We don't have equal access across the country. And what about world distribution? The U.S. we're third dosing, people in the U.S., and there's countries that haven't seen a dose at all.
Yeah, exactly. And that, because is a child to a Syrian mother in a refugee camp any less precious than a child in Beverly Hills?
Absolutely not. No one would agree to that. So, everyone thinks that we should deal with this. And I think it's a very deep issue. I'm not a politician, but there's national sovereignty, there's taxpayer dollars, and so on. But I think the point is the pandemic, it raised all these questions. That these are not hypothetical sort of war game scenarios. These are real issues that affect real people. And we need to go back and say, next time, what can we do to make it more equitable? Yeah. Particularly in our country, I think this is solvable. And it would have, collateral benefit, actually. So not only in pandemic times, but we also have health inequities every day. And I think if we can continue these conversations, the whole, everyday life will be better in our country and in the world. So raising the issues of equity has been really great. Particularly in my area, we've learned a lot of things just from a medical or a technical approach. So, for instance, we've been using antibodies as an IV infusion. You go to an infusion center, you make an appointment, they put an IV in, you sit there for an hour or so, you have to hang out afterwards for a while. And that's been helpful to get these antibodies out. But it'd be a whole lot better if you could just drive by, get a shot, and be done with it in about 10 seconds. So the partners that we've been working with, AstraZeneca is the pharma company, they formulated theirs as IM. And it's taken a little bit longer than some of the others, but that's going to be great for these immunocompromised people who don't want to hang out in the hospital for an extra hour. They could even get this through home health as a shot. So shots versus IV, that's a lesson that we want all the future ones just to be a shot. And then the conversion from using antibodies as treatments, someone's sick and we give them the treatment. Now we've been able to convert these to long acting. They hang out for many, many months. And so it's the first time we're ever going to use antibodies to prevent a disease. And we're going to, inoculate all the immunocompromised people instead of vaccine. And so antibodies are an important technology, but we've never really used them for prevention. And we're learning it works. And so
how exciting.
If I could give you a shot, that protected you from an infectious disease for a year or more, and It's not lifelong protection, but for a lot of these infections we're dealing with, we know we can do it now, and we should do it. So that's part of the underpinning of the Head 100, that vaccines are desirable, but they're pretty complicated to develop, whereas the antibodies are pretty straightforward. We give you instant immunity from an antibody from one person essentially to another, and you're done. So that's been exciting for me. Put the last 25 years of my life into this technology, and now we're seeing it being used in thousands or millions of people, and it's going to be used in the future even more.
Oh, Dr. Crowe, I know I was communicating with Renee during this, and Renee says that she has some questions from the people that have been in the audience that have been watching us. And so, Renee, would you come on and talk to us and give us some of the questions and see what Dr. Crowe can share with us, please?
Certainly, yes. And we won't be able to get to all of them, but I'm trying to collate. Sue McKenzie, she says, I've had my 2 shots of Pfizer. Now it looks I'm going to need a third because immunity wanes after a while. Does this mean that every 6 months to a year, we're going to have to get another booster? Will the body ever build up a lifelong immunity like it does like mumps and measles and TB?
That's a great question. So this is the first time we've used mRNA vaccines, and so they're amazingly safe and amazingly effective. So I'm pretty excited about them. But now it's true, we're seeing a waning of immunity. And for each virus that we deal with, there's a different duration even after a natural infection. So we're just sort of learning, how does this work for COVID? If you look at other diseases that came into the human population and occurred over and over again, at some point, flu is sort of, or the different various flus that have crossed over, sort of a good model for this. The first few years, you see a lot of deaths and a lot of severity, but at some point, a lot of people have been exposed or vaccinated, and you start getting the situation where the amount of virus on the planet goes down, basically, and your exposures go down. The amount of virus in each exposure is lower because people are partially immune. And so eventually the virus gets, experts would predict that SARS-CoV-2 would eventually become more like a common cold, or certainly more like flu in the intermediate period, and eventually like a common cold. And why do we think that? Well, there are other coronaviruses. There's one called OC43 and one called 229E, and another one called HKU1. And people have those all the time. They're coronaviruses. They get them in their nose. It causes a common cold syndrome, and that's about it. Almost nobody gets severely ill from those. And we believe those came into the human population a very long time ago, and they sort of burned out, and now they're just common cold viruses. So that's what we're trying to get to with SARS-CoV-2, is get a lot of people immune in the world to slow the whole thing down, and then have it become weaker and weaker and turn it into the common cold. I think that's our expectation.
Oh, wonderful. Thank you. Renee?
Yes, thank you. So someone else wanted to know, how do the Moderna and JNJ vaccines differ in how they respond to the body?
Well,
how is J&J different?
Yeah, so there's different ways to make vaccines that have been developed over the years. And the Moderna and the Pfizer-BioNTech vaccines are a new type of vaccine in which we're not putting a piece of the virus or a weakened virus into people like most of the childhood vaccines that we've all gotten. We're actually putting the gene, it's an RNA in this case, it could be a DNA in the future. We could also have a DNA injection, and that's been worked on as well. But we're putting the code, and your body is the factory. You take the messenger RNA and you make the vaccine in your body, basically. You make the protein that is the virus protein, which is safe, and you immunize yourself, basically. So Moderna and Pfizer are RNA that is the recipe to make the vaccine in your own body. Now the J&J does it a little bit differently. It also puts the gene in there, but it puts it inside a weakened virus, and that weakened virus comes in and delivers the DNA into your cell, and your cell uses that recipe. So they're kind of just different delivery systems, and Moderna and Pfizer are actually coated in a lipid. It's sort of like the cell membranes that are in your body are made of lipids. So those genes are put in by lipid, whereas J&J is using a virus to deliver the payload. And it's a very similar idea, but one's a virus and one's an RNA and a lipid.
Wonderful.
Wonderful.
Do we have time for maybe two more, Dennis?
Ask Dr. Crowe.
Doctor, do you have time for maybe two?
I'm
maybe
good.
three
I'll
more?
keep going as long
Okay.
as
There's a lot of, we won't be able to get to anyone. Some of them are duplicates, but people tend to have similar questions. Someone else wanted to know, in general, is the body affected adversely by getting increasingly more vaccinations within a given time period? Like, can you get too many vaccines in a certain time period and it adversely affects you?
Yeah, that's a good question. And it's a normal thing to wonder and maybe have a little bit of fear about that. And the answer is not as far as we can tell. So the best example, I'm a pediatrician by, my original training was pediatric infectious disease. So if you drop your kid off to daycare, they are exposed to a very high titer of respiratory viruses about 8 to 10 times a year. So kids have runny noses and they're all sitting in together and they're all getting inoculated with an unaltered wild type respiratory virus. Could be flu, RSV, things like that. And this happens 8 to 10 times a year if you're in daycare. Also diarrheal viruses. So they're actually putting things in their mouth, which includes diarrheal viruses from the kid in their class. So kids are getting infected probably every 2 weeks or more with wild type viruses, and they do just fine. In fact, this is part of growing up, and it makes them, by the time they're in kindergarten, they're already partially immune to dozens, if not hundreds of things. So your body is made for that. So if you come back with, 1, 2, 3 vaccines, it's just not even comparable to what we're already doing in daycare or, living in normal circumstances. So the body has an enormous capacity, the upside here, and the number of vaccines that we give people is tiny compared to the human immune system capacity. So I personally I wouldn't worry about that. And I can give you one more example. In the U.S. military, there is a program that changes over time, but it's called the Special Immunizations Program. And they use experimental vaccines in those people because some of those people go into the biosafety level 4 labs and work with things to understand how they infect and kill people. And so some of those people have gotten hundreds of vaccines for things none of us would ever be exposed to, and they're fine. I'm not saying you would never have a side effect from a vaccine, because you can. There are minor side effects from many of these things, fever or soreness of your arm. But the question is really about the number of vaccines, and these people get repetitively immunized with a lot of unusual things in addition to all the other things we get, and they're fine. So I understand why that seems concerning, but the answer is human body has an unlimited capacity to respond to these things.
Okay, so that leads us right into, how does the coronavirus affect children differently than adults, and what would you say to parents who don't want their kids to get the vaccine?
Well, usually kids are more vulnerable to viruses because they've never seen them, and they're, very young children have a relatively immature immune system. This has been kind of backwards, in which kids have been spared the major toll of serious disease, ventilators, dying. And we don't fully understand that yet. I think people are trying to figure that out. There is a substantial amount of disease. I'm not saying there's no disease, but if you compare an 85-year-old person in a nursing home to a 2-year-old kid, their risk is not comparable. So kids have been spared. I think the reason to do as much of the population as possible is, I've already talked about that, is like getting to a population immunity where we stop passing it around, and when we do, we pass around less virus. So you're getting bombarded with less virus, and we're trying to get to the endemic and then common cold stage, and kids need to participate in immunity at some level. And if I were a parent, I think most parents just want to do the right thing for their kids.
Yeah.
I mean, they're willing to participate in public health initiatives, but they're really thinking, what is the best for my kid? And all I can say is the FDA does not approve these things until thousands of people have received them under controlled situations and looked at very, very carefully and followed out. And the vaccines look very safe and effective in kids, and so I recommend them because of their approval. But I understand the complexity with parents. It's a complicated decision, but getting kids to immunity allows the entire population, including them, to get back to normal, which is what everybody wants.
Exactly. Even though the new normal is anything but, as we have seen with your being able to have Zoom meetings, people off site, you can communicate and collaborate instantly with people around the world, with scientists around the world. How quickly can you get to a solution that you wouldn't have before?
Right. Well, we lost a lot in the pandemic, in a social and emotional and other ways. But I think we're sort of in a liminal space between the old and something new that's greater and more powerful and a better life for all of us. But we've got to, get through the mourning phase of what we lost and accommodate to the new opportunities and the new technologies. And I think there is a lot of good potential. People thinking they could live anywhere. People thinking having more control over their work and their family life, less commuting. Those are exciting opportunities that just we've opened our mind to, and so many other things. So it's a mixed experience. We're still mourning, and we've still lost, and that's why I say liminal space. We're in between. We're on the threshold toward a new place, and I think we just have to be patient with ourselves and kind to ourselves and say, "Wow, that's hard. It's still kind of going on, but there's going to be a place on the other side of this that has opportunity for even better." And I'm optimistic about that.
A lot of questions about common cold vaccine. I'll let that be the last one for now. But why do we not have a common cold vaccine, and are we going to get a common cold vaccine?
Good question. So the common cold is a syndrome, meaning
I'm in the show right now. Did you need something?
Signs, and but there are many causes of the common cold. So the most common cause is called rhinovirus, but there's not one rhinovirus. There's over 100 of them, and so we can figure out any one of them, but we would currently need 100 drugs for 100 rhinoviruses, and on top of that, all the coronaviruses and all the flu viruses, and you end up needing hundreds of medicines or vaccines. And so what we're grappling with is, are there any sites of vulnerability on, say, the 100 different rhinoviruses that's always the same? Is there something on there that we can latch onto that would get them all? And that's where our research is. And this isn't easy. If it was easy, we would all be done. So we're searching around, watching human beings respond with their own natural immune system and kill rhinovirus. And we're doing that over and over for different ones. And we're looking for the golden ring, which is an antibody that will recognize the same place on all of them. Then we'll have an antibody for the common cold, and then we can build a vaccine, based on that principle. So I think I'm cautiously optimistic about that. But it's the variety of viruses that cause the common cold that currently stymies these efforts.
Oh, Dr. Crowe, thank you. As always, if you think you're going to get out of my asking or having you on a show, no way. There's so much I want to talk about, because there is the scientific, there is the emotional, there is the spiritual components. All of these intelligences are moving forward, and we're moving forward. It feels like that we're at a time in the world when something very powerful is happening, that the human being is going through a shift and a change in our consciousness, and it's amazing and scary as hell, but it's amazing to be part of it. And thank you for giving us your expertise, and thank you as always for giving us your time.
Yeah, thanks everyone for joining. I appreciate you listening.
Good, and all right, thank you everybody, and we will see you on Reasonably Spontaneous Conversation next time.